Hello everyone. In this question, we are given two strings S and T. What we have to check is if it is possible to have a smaller version of S, a substring that has all the characters present in string T. We then just return the substring which has the smallest length. Now, let's look at the constraints to get some additional information. The strings will have at least one character and can go up to 10 raised to 5. It means we won't be encountering any empty strings. The other important thing to note is it can only contain uppercase and lowercase English letters. So what if I find multiple substrings of the same length? There will be only one unique answer and the test cases ensure that. Can T have duplicate characters? S and T can have duplicate characters. Do the order of the alphabets matter? No, the order of the alphabets do not matter, and we can return the substring which looks completely different from the string T but just has all the characters. Can the length of the string T be greater than the length of the string S? Yes, it can be, and in that case, the answer will just be an empty string. Okay, that was a lot of information. And now coming to the approach to solve this problem. We use the combination of two things. First, the sliding window, which is a modified version of two pointers. Here we have two pointers, one on the left and the other one on the right, marking the start and the end position of the substring. When we begin the iteration, both of them will be at the start of the string. Second, we have the hash tables, and these are to look up things extremely fast. Here we use them to store counters of the characters that are present in the string. Here we can use the counter method because the order of the alphabet doesn't matter and we are specifically concerned with the counts. We are keeping track of a couple of things here. The first one, the two pointers. The second one, the current count of the letters which are also present in T. The third one is the sides of the window. And the fourth is the count of the letters we have in the window so far. We start with the right pointer and see that if it is at A, we increment the current counter by 1 as A is present in the given substring T. The right pointer then increments and moves to the next letter, which is N. We add that to our window hash table. We keep repeating this process till we reach current equal to 5. This tells us now we have all the characters of T present in our string S. So we have at least one substring which could be returned as our answer. So right now we have the window size which will be equal to 12. We then start moving our left pointer to see if we can shorten this length after we remove some characters. Every time we do that, the length of the window reduces. We start removing characters from our current window hash. And if we don't have the characters in our window hash which are present in the given substring hash, we decrement the current counter. We keep repeating this process till we reach the end of the string S, and in the end just return the substring which has the minimum window size. Let's look at the code to understand this better. First thing, we start by checking if the length of the string S is less than the length of the string T. And if that is the case, we just return an empty string. We now define two hash tables, one for T string and one for our current window string. We then count the number of alphabets and map them to their respective counters for the string T. We use for loop and get the function in a dictionary. This allows us to use a default value if the key is not present in the dictionary yet. This usually happens when we are encountering the element for the first time. The next thing is we are going to use two pointers, that is sliding windows, to iterate through this array, and so we have a left pointer and a right pointer. We also save our window size along with the pointers in a tuple. We will start with two loops, one to iterate over each character and second one to determine our window. So what conditions can be used to get there? First, loop is quite simple. The right should be less than the length of the string, so we don't go out of bounds. We keep incrementing the right pointer at the end of the first loop every time. For the second loop, the first condition should be left will always be less than or equal to right. So during each outer iteration, we add the character entry to our string hash table if the character was not present, and if it was, we just keep incrementing the counter. Now mostly left will always be less than or equal to right. How do we decide when to enter this second loop? We need two counters, one required and the second one will be the current counter. t. So required will be equal to the length of the hash table of the given substring t. And the current counter will increment if the counter of the characters in the window hash table matches the counter of the characters in the t hash table. This current and required will give us the second condition for us to get inside the second loop. Now we focus on the character of our left pointer. We need to compare characters at our left pointer same as we did with the right pointer. There are still three things that we need. The first one is the window size to compare, which is the smallest window, and save the left and right pointer values for that minimum window. And once we have that, to exit the loop, we will reduce the counter of the characters and then compare the value with that of the dictionary of the t string. And during each iteration, increment the left pointer just like we did with the right pointer. In the end, we just return an empty string if we did not encounter all the characters in string S. And if we did encounter characters in string S, we return the substring which has the minimum window size. The output for some of the test cases looks like this. Looking at the time complexity of this problem, the outer loop is dependent on the length of the string. So access to memory is dependent on that. That is O of m. The first outer loop to format a dictionary will be O of n. The inner loop is dependent on the outer loop's right pointer, so it can never be another O of n. So that will be constant. And so the total time complexity of this entire problem will be O of m plus n. For the space complexity, we are using a few variables and two hash tables whose maximum size can be up to 26 characters. So the space complexity is constant. Okay, that was it for today's problem. How do you think we should approach the problem if the order of the output string does matter? Please let me know in the comments below, and thank you for watching the video. If you like my explanation, please hit that like button and subscribe to my channel. It acts as a motivation for me to make more videos. I would also love your feedback on what would you like me to improve about my content. Thank you and bye.